What's going on, everybody? Good afternoon. Hello. Hopefully everybody is doing well. For those of you that have jumped on here with me, thanks for stopping by and hanging out with me. We're going to be doing a BGP dive this week. Gets us out of the iGP and keeps us moving forward with what we're going to be talking about as we move forward with the CCNP stuff. So I'm pretty excited. So for those of you that have ever wanted to dive into BGP, that's basically what we're going to be doing today. I'm going to get you guys acclimated to some of the concepts of BGP and stuff like that. So good stuff. So I'm going to go ahead and kick us off. We're going to go ahead and we have our topology that we've been using and stuff like that. So we're going to get this bad boy started. What's going on, everyone? Hello. Thanks for stopping by. I'm going to dive right into it. I'm going to do some recording as we go along, so if it sounds like I'm recording a video, it's because I am. So we'll go from there. So if you guys have any questions, feel free to ask them in the chat. I will do my best to answer them to the best of my ability. Go from there. So how's it going, everybody? In this video, we're going to be going ahead and taking a look at an overview of BGP. So this is part of a live stream as well, so if I'm answering questions or I'm back and forth, there's a reason for that. So BGP, it's actually a rather involved protocol. If you weren't already aware of how BGP works, there's a lot that goes into it. So one of the things that you really need to understand in terms of how BGP works is what BGP is and how it comes into play. So BGP in and of itself is another routing protocol that you could use, but you don't use BGP internally. There are some, I guess you could debate it a little bit, I can use BGP internally. You kind of sort of can, but it's just not a smart move to do. Because BGP was never designed to replace your interior gateway protocol or your iGP like OSPF, eIGRP, RIP. That's not its goal or its intention. BGP, pardon me, BGP is designed to route very large routing tables based on the way it's developed. So it is designed to allow one autonomous system and another autonomous system to form connectivity with each other and then do route exchange. Now, BGP is actually an application and not a routing protocol. It's a reachability protocol, and this is one of those things that as you start diving into how BGP works and stuff like that, it isn't set up like an iGP. It's not set up or going to work the same way that an iGP does. So let's talk about that for just a second. What does a iGP do? Well, an iGP, RIP, OSPF, eIGRP, ISIS. We're going to remove ISIS from the conversation right now because it's technically a layer 2 protocol. RIP, OSPF, eIGRP. Those protocols themselves use link local multicast between a couple of routers on the same subnet to discover each other dynamically, right? So they're going to send hellos to a link local multicast address. They're going to listen back and forth for each other. They're going to discover each other. They're going to form a dynamic adjacency, which is going to continue to use the hellos to make sure that adjacency stays online. And then you're going to do route exchange with each other, right? Now, BGP doesn't do that. BGP is a manual configuration. There is one scenario where BGP is not manually set up with what they refer to as dynamic neighbors. Dynamic neighbors allows you to scale BGP dynamically. So for example, if you have a very large WAN connection setup where you've got like a couple of hubs, you've got multiple spokes, and you're doing something like DMBPN, or Flex VPN. Those scenarios do come into play. Or for one other example that you could use is in a very large service provider. If you've got a very large MPLS Layer 3 VPN or a very large just regular internet service provider using BGP, you could use dynamic neighbors to bring on new provider edges. But that's a specific use case. You're looking to dynamically add hosts or spokes as you grow. There's nothing wrong with that, but that's not the goal of BGP, right? BGP is manually configured, and once it's manually configured, basically what you're doing is you've got two different neighbors that want to form a peering with each other. I say peering because it's got to be manually set up. So you have your peering that's set up between two different routers, and once your peering is up and running, then you have the ability of propagating routes. So BGP, for those of you that are not familiar with it, is the protocol that runs the internet. So if you're trying to go to Facebook, if you're trying to go to Google, if you're trying to go to Twitter, Snapchat, whatever particular endpoint you're trying to reach or service you're trying to connect to, BGP is going to play a part in getting you there. So as soon as you leave your home network or your company's network and you try to go anywhere on the internet, BGP is how you're going to get there. So that's one of those key things that a lot of people, especially when they're brand new to it, they know that BGP is an exterior gateway protocol, but they don't realize that BGP is the protocol that runs the internet. So if BGP wasn't around, the internet would not be around, because you would need some way to scale the internet connectivity. Because the last time I checked, there were the neighborhood of almost 800,000 routes in the BGP table. That's a lot of routes. So yes, it can scale pretty dramatically, but it's also one of those things where when you start diving into how it works, you have the process of setting up your peering and then doing the route propagation. So the cool thing about it is BGP can scale and scale very, very large. Now, one of the other things that I like about BGP is, unlike a iGP, where if you're going to have a bunch of routers all peering with each other, forming dynamic adjacencies and stuff like that, what you'll end up getting is, thanks Thompson Lover 2, I appreciate that, man. Thanks for becoming a member. You'll have the adjacencies come online and routes will be propagated, right? But if something happens with that link, what will end up happening is the protocol will automatically remove that route from the routing table. And during that time frame between the route flapping and then the reconvergence and stuff like that, that particular protocol is going through convergence, right? That's figuring itself out. BGP is never going to be 100% convergent. This is never going to happen. Where iGP works best when it's 100% converged. If there's a convergence event in any one of the protocols, RIP, eIGRP, OSPF, you're going to have to reconverge around that failure, figure out whatever path you need to take in order to get to where you got to go. Why that's a big deal is because with iGP, you're dependent on the direction that you're going to be taking a path. So for example, if we were to look here between router 5 and router 6, what ends up happening is if this link goes down, that the way that iGP calculates the routes and figures out where to go is based off of all known links. So if I do any traffic engineering with any iGP, RIP, eIGRP, OSPF, I'm modifying values at the link level. So for example, RIP is a little bit different because it goes based off of hop count. So, thank you. Appreciate the shirt compliment. You do you add in hop count. So I forget the actual modification you have to do under the protocol, but you have to modify RIP to the hop count. So you basically have to, I forget the actual syntax because I don't deal with RIP very often. The OSPF, you go to the link level and you modify the cost, right? So if you adjust the cost on a link that would normally be the primary path, and you adjust that cost to be higher than another path, then that link is no longer going to be used in the forwarding of that traffic. Another link will be. eIGRP, same thing. Whether you modify the delay or the bandwidth, that particular path that you were taking, if you modify it at the link level, you're affecting all traffic that flows over that link. So when you get into a situation like that, that makes the link dictate how the protocol will forward traffic. BGP doesn't do that because the link itself, BGP doesn't care about. BGP is looking at attributes of the route itself. So, sure thing, no problem, Zahid. When you look at the attributes, there's a number of them, 12 or 13 off the top of my head. And those attributes are what help BGP figure out where it's going to go and how it's going to get to where it's got to go. Now, in a situation like that, if I look at IGP, again, you're dependent on the link. So if you make a modification at the link level, it's going to affect all traffic that flows over that link. Where BGP, you can affect things at the autonomous system level. So you can say, for example, with an AS path list, you can say any routes that are received in from this AS path or this autonomous system number, you want to associate this particular attribute to that. It could be local preference, it could be MED, it could be AS path prepending. It really depends on how you want to affect how BGP works. Where I could also take those same attributes, and I don't have to associate them directly to an autonomous system. Autonomous systems are more generic because of the fact that you are being specific to an autonomous system, but you're also any routes that come from that autonomous system are going to be affected by that attribute modification. Where if I go in and I do a modification at the prefix level, meaning the actual subnet itself, I'm associating that path attribute to that particular prefix. Or I can do it from the neighbor. So if I whatever routes I receive from a particular neighbor or set of neighbors, I can affect those particular routes received from that neighbor with those path attributes. That's where the real power of BGP comes into play. Is you're not a BGP doesn't affect the underlying routing protocol. It affects the routes that are coming in. So whatever routes I'm receiving in, I can apply path attributes to those specific routes, and or any to the routes that are being learned, whether it's coming from the autonomous system, the route itself, or from the neighbor the routes are coming from. That really gives me a lot of flexibility. Where IGP, I don't have that capability. I can't go to IGP and say, for a particular prefix, I only want to take this particular path. It's very, very difficult to pull that off, if not impossible. So these are some things that do come into play that it's a big differentiator between IGP and BGP. And this is something that I see a lot of folks that get into BGP initially, they don't get that. That's all out of the gate. That's why I'm talking about it. So we have that. BGP does support both IPv4 and IPv6. It also supports several what they call subsequent address family identifiers, or SAFIs. So there's two main AFIs, address family identifiers. The first one is going to be IPv4, the second is going to be IPv6. So literally 1 is IPv4 and 2 is IPv6. Then you have multiple sub-AFIs. So you have unicast, multicast, VPN-v4, MVPN, MDT, so on and so forth. There's a number of them out there. We're going to be taking a look at some of the basic stuff here. We'll take a look at IPv4 unicast, IPv6 unicast. We will be taking a look at VPN-v4 and VPN-v6 when we get into MPLS VPNs. We'll be taking a look at VPN or IPv4 and IPv6 multicast. Once we get into the multicast section, I will be taking advantage of BGP to do the route propagation for multicast routes, because it can do that as well. Some of the ones we won't be taking a look at are going to be like your VPN or your layer 2 VPN, eVPN, or VPLS. We're not going to do any layer 2 VPN. We're not going to be looking at VXLAN, eVPN. We're using BGP as a control plane for the MAC address propagation. We're not going to be doing any of that stuff here. I will be taking a look at those. If you want to know more about layer 2 VPNs, go check out the Service Provider stuff that I've already done on the channel. Check out the Service Provider playlist. on the channel, and that'll go into those details. I did a pretty deep dive on layer 3 and layer 2 VPNs. So if that's something you want to know about, go check those out. I haven't covered VXLAN in any real depth on the channel yet. I plan on doing that in the near future, but right now I'm trying to work my way through this very large series of videos. There's a lot of content to create, so I'm slowly working my way through it. Now, BGP is not a protocol, it's an application used for reachability. So you form a peering between a couple of routers and then you propagate routes. Fairly simple stuff. As long as you keep it pretty simple, BGP is actually very, very easy to work with. And my goal here is to keep things simple. I'm not going to go into any super deep dives on some really oddball routing designs or anything like that, to where we're having to make lots of modifications to the routing topology in order to get things to work. As I'm not trying to do a super deep CCIE deep dive, I'm trying to keep it more geared to those of you that are looking to get your CCNPs and stuff like that. But because the fact that this series focuses on Encore as well as an RC, we'll be taking on some of the more complicated aspects of it. We'll dive into those deeper concepts, but I'm not going to go into any super crazy, overly complicated BGP implementations. Although the reality of it is, if you take BGP and you were to, like, for those of you that are familiar with what an accordion is, you know, when you have an accordion, when it's not being used, it's completely collapsed. But if you take an accordion and you stretch it out, you know, you get that little flexible piece in the middle there, stretches out, right? Well, if you take BGP and you expand all of its different features and capabilities, well, that's basically what I'm going to try to walk you guys through. Is if you were to look at, you know, how to get the route, the peerings up and running, how do you do configuration scalability through peer groups and templates, and then doing route reflectors and confederations and things like that, and then do your route propagation. How do you do that? Communities, aggregation, stuff like that. Then the BGP best path selection process, communities. I don't know if I already said that or not, but when you start taking BGP and you start expanding it and you start to kind of untwist it and understand all the different capabilities that it has, you realize how involved it can be. But then you can break it down into chunks. You can chunk it out and be like, okay, I'm going to focus on this particular part of BGP, then we're going to work our way into the other ones. And it makes BGP that much easier to deal with. Because when you really break it down into what you're trying to accomplish, it makes BGP actually fairly easy to understand. And you're like, well, BGP isn't that complicated. So it's when you start chunking it up, it makes BGP easy to approach. So there's a couple different things that come into play when it comes to how BGP works. BGP has a couple different ways of taking the routes that you actually want to advertise and actually advertising them. The first of which is going to be provider independent. We'll start with provider aggregatable. Provider aggregatable means that you are buying access from a service provider that has their own BGP implementation, and you're basically going to let them advertise your address space, and that's what you're going to let them do. You're going to let them advertise the address space that you're using. So for those of you that have home internet right now, and like I have my home internet right now that I'm using the stream from, I don't have a BGP peering to my provider. I have an internet connection at my house, and that internet connection allows me to reach the internet. But what's actually happening with that connection is I have a public IP address range that I've got, and what ends up happening is the provider has a peering to other BGP peers, and the subnet that has been allocated to my internet service is advertised into BGP by the provider, right? So what ends up happening is all the other internet routers in the internet now know about my public address space. Because of the fact that I have an ASA firewall that terminates my internet. My ASA firewall has a public IP associated to it. When that public IP address is advertised out into the internet, traffic on the internet knows how to get back to me. Because remember, the routing is bidirectional, so you need to be able to get out and back in order to get to where you got to go. If you can't get back, or that's a bad thing. Then the path is broken. Think of it like if you were to be at your home and you want to go to the grocery store, or you want to go to the movies, or you want to go to some destination. Routing is destination based. So wherever I am to wherever I want to go, there's got to be some sort of path from me to the destination that I want to reach, and there's got to be a return path. It could be a different set of roads that you travel, or a different set of internet links that you flow through, maybe a different set of service providers that you pass through. But whether you go, 1, 2, 3, 4 or 2, 4, 5, 8 doesn't really make much of a difference, as long as both ways can get back to where you are starting from. That's the key thing. Routing is bidirectional. You can go out, you got to be able to come back. That capability and that understanding really ties into how internet routing comes into play. So as long as the provider is advertising your internet circuits for you, you're in good shape. Now, this means that you're just getting internet service from them. Now, can you form a BGP peering with the provider and then still have them advertise the routes for you? You can, absolutely. I've had many customers do that. Now, the other side of the fence is, what happens if you want to go own your own address space? Let's say you go out and you have your own /24 or your own /16 or whatever size subnet you need. Is that possible? 100%. You can go out there, and there's a number of auction sites on the internet that you can go and put down a bid for an address block that happens to be opened up. And you can go through the process of going from the auction site and then going through IANA and going into your account, and then having that particular address space that belongs to somebody else that gets transferred into your address space or into your account, and you become the owner of that address space. And then from there, you can go to the provider, whoever you want to peer with, and be like, okay, I want to use my address block, and I want to go ahead and set up a BGP peering with you, and then I'm going to advertise that route on behalf myself. I'm going to go in there, I'm going to set the network statements. But I need you, the provider, to go into your filtering rules and allow those routes to get propagated. Because the provider is going to have their own set of filters in place when it comes to allowing that stuff to happen. They're not just going to allow you to advertise whatever. Like, you can't advertise RFC 1918 address space, the 10 net, the 172 net, the 192.168 nets. You can't advertise those on the internet. So providers are going to have like a front end filter that are going to block those subnets from being advertised. And because of that, you're going to have to make sure that they're only propagating what it is that you need to send. Now, I've worked with some providers in the past where they've gone ahead and you're propagating you advertise, say, your /24. You configure your interface with an IP address in that /24 range. The provider's got their IP address that you basically give them that they're going to configure on their device. You form your BGP peering, and then the route gets advertised. Fairly straightforward concept. Everything works great. If something happens, the provider's they're only responsible for the peering, right, on their side. You're responsible for your peering. If there's no reachability, the provider's not on the hook for that, because they're not in control of your equipment. They're not in control of your environment, right? And that's where the autonomous system concept comes into play. What exactly is an autonomous system? An autonomous system is a administrative boundary or domain. That's the way I like to reference it. So, like we talked about eIGRP and the autonomous system. The eIGRP autonomous system is going to be used to dictate the flooding domain, or how far a particular route will flow. Well, that's similar to how BGP works, but also different. A BGP autonomous system number, one router can exist in a BGP autonomous system number and it's completely okay. But it can form peerings with other BGP routers and other autonomous systems. eIGRP, you can't do that. You can't be on router 1 and be autonomous system 1 and be on router 2 and be in AS2 and form an eIGRP peering. That will not work. You have to be on the same autonomous system number with eIGRP. BGP, you don't have to do that. In the internet, you're going to have lots and lots of autonomous system numbers, or ASNs. They come in two different values. You have the 2-byte value, which is 16 bits long, which are going to be, let me go ahead and start taking some of these specific details and draw them out here. And I did get some feedback to not use red anymore because apparently it's too it's hard to see. So I will go to white based off of some feedback that I had. So with the autonomous system values, with the ASNs, you have 0 through, I'm sorry, let's go, technically it's 65,535 is going to be your range value. Your public ASNs are going to be 1 through 64,511, and then so this is going to be public, and your private is going to be 64,512 through 65535, right? So you're going to go ahead and you're going to want to get an address range if you're going to be routing on the public internet in this range right here. That's what you're going to want to grab. Now, what happens if you've got 64,512 through 65535? Can you still use that on the internet? You can. The only difference is with this one here, the provider is going to have to add in a command on your neighbor statement that's going to be remove private AS. So if you peer with them with a 65535, for example, and they're 2178, which I don't know why that number came off the top of my head, but 2178 is the provider that you might be peering to. They're going to receive your routes in. So if you advertise a subnet in of say 101.6.8.0/24, and the source autonomous system number is 65535, and you're peering to 2178, what'll end up happening is 2178 will receive this prefix from this source autonomous system number. What'll end up happening is this AS number will actually get stripped off, and the route right here will actually get advertised as 2178 to the rest of the internet. That's how you can peer to the public internet with the private AS, and the provider is still able to propagate your routes for you. That's one way of getting around it. The other one is going to be the 4 byte. You have the 4 byte, so this is 2 byte. Then you have 4 byte. 4 byte is take 2 byte and multiply it by 2. So you've got 0 through 65535 dot 0 through 65535. So this is going to be 32 bits because it's 4 bytes. And what you end up doing is you get what they refer to as AS dot. And what that AS dot comes into play is it will, on older routers, what you'll end up getting is I believe it's a 2, 3, 4, 5, 6. If you're on a router that doesn't support AS dot capability or doesn't understand the 4 byte autonomous system number, you end up getting that value. Where when you have a router that does support AS dot, you can go onto the router and type in global config AS notation dot on iOS, and I forget what the XR variation of that is. I'll have to look. I think that might be AS notation dot. But the purpose of this is to give you more scalability with your your autonomous system numbers. So if you're doing the non-AS dot format, I don't know how the correlation comes into play where you get 61.527.3. This would be like 21.12, right? Now I'm not saying that's the exact correlation to it, but if this is your non-AS dot format, and this is going to be your AS dot format, then how it's added in, I honestly don't know. I never read into that because not that I didn't care, just I didn't understand it. So if you are going to be using a 4 byte autonomous system number, it's a really good idea to make sure that all routers in your administrative domain, your autonomous system, are configured to view the autonomous system that's being received as AS dot. And that's going to make it easier down the road and long term for you to get everything up and running. So that's just some high level details on how that comes into play. Now I'm going to go ahead and clear the screen. We'll talk about a couple different types of iBGP or BGP peerings. The peering types, there's two. You have iBGP, which is going to be referred to as internal BGP, and on a Cisco router, that's going to be an autonomous or an administrative distance of 200. And this is going to be a peering from one router to another router in the same AS. So same ASN peering. So if I'm on R1 and I want to connect to R2, and R1 is in AS 120 and R2 is in AS 120, and they form a peering with each other, this is an iBGP peering. This is very common if you want to do BGP as your overarching routing protocol. This is a very common thing to do. There's a couple different ways to pull that off, and we'll talk about those here in a few minutes. The other part of this is going to be eBGP. This is going to be external BGP. And if I am using this, it's going to be an autonomous or administrative distance of 200, where it's going to be different ASN peering. And the concept here would be if I am doing R1 to R2, this guy would be 1, this guy would be 2, and we're forming a peering between each other. This is eBGP. This is where the exterior gateway protocol concept comes into play. And that's the real differentiator between the two. Once you understand that, you understand the basic constructs of how BGP works. That's really the main differentiator between the two, and the administrative distance that goes into with that. Now, as we get further into the meat and taters of how BGP works, we're going to talk about how the propagation works, how to set the peerings, and all that type of stuff that comes into play. So that is the beginning part of the breakdown that I wanted to cover in terms of how it works and stuff like that. So what we're going to go do is I am going to stop this recording real quick because we're done at this point. So thanks so much for stopping by, guys, and we'll catch you guys in the next video. The next topic that we're going to bring up is going to be how would you go about setting up a peering, and what would that process look like. So let me go ahead and start the next video real quick. How's it going, everybody? In this video, we're going to go ahead and talk about the different BGP peering types and how you would set those up. So the concept is actually relatively straightforward. If I am sitting here we have a couple of different autonomous systems we're going to be working with. We have this autonomous system right here, and we have this autonomous system right here. And I built these two out specifically for this setup. So, and I'm going to draw these out in different colors. So I'm going to choose, let's go sky blue. This will be all of my iBGP peerings, right? iBGP, 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 iBGP. This will work just like that. And that's basically where that will come into play. Same thing up here. Now I'm going to do a full mesh over here. So this will be a full mesh. And then over here, we're going to do a route reflector design, where we're actually going to take autonomous system 100, and I'm going to make, this will be what the public sees. We're going to break this down into two different confederations. I'm going to have confederation 1 here, which will be 136, 136, the router numbers. And over here, we're going to have another confederation. This will be 245. Okay, what we're going to do is this guy right here and this guy right here will both be route reflectors. Now, we haven't talked about route reflection, but we're going to. That's going to allow these guys to connect to here and here, like so, and then here and here, like so. And then any routes that are taken from this guy and propagated outbound are going to be propagated to this guy and then sent down to here. Again, we haven't talked about route reflection yet in much detail, but we will. All this stuff internally is iBGP peerings. Now, Another thing that we'll do is we will do a peering between 6 and 5. This will also be an iBGP peering, but it'll also be referred to as a Confederation eBGP peering, because we're going to be peering between two different confederations in the setup. We'll do the same thing over here. So we have all that connectivity up and running. Now I'm going to switch over to, we go to yellow-green. Between the providers, we're going to have this one link right here, right? This guy right here will be an eBGP peering, meaning we're going to be peering from one provider to the other and getting all that squared away. Now, any connectivity that we do between the providers is going to be eBGP, one autonomous system to the other. I'm going to have an eBGP peering from here to here. I'm going to have an eBGP peering from here to here. And then I'm going to have an eBGP peering on 45. We'll do one to XR21. And then this one here, we're not going to peer this one here. We're not going to do a peering. I'm going to simply take this particular prefix, the 200.8.46 subnet. I'm going to advertise it into BGP for reachability, because we don't have to form a BGP peering in order to propagate the route, because all we have to do is have something that's directly attached to us and advertise that into BGP, and that's going to provide the reachability. Basically how we're going to accomplish that. So that's basically where that'll come into play. I'm going to first start off with this guy here in the middle. So let's talk about that real quick. If you guys have any questions on anything that I'm doing, let me know, and I will answer any questions in the live stream in the chat. But I'm actually going to clear the screen off. Now that you know what we're going to be doing, we're going to talk about the different, how you can set up iBGP peerings, because we're going to have to spend some time breaking that down and then going through the actual configuration steps. So let me go ahead and clear the screen off real quick and talk about how that will come into play. Let me switch back over to white. So when we talk about iBGP peerings, we have a couple different variations that we need to understand. The first one is going to be a full mesh, because we have some rules that we have to understand about how BGP works. With full mesh, you have, in order for routes to get propagated, an iBGP route can only be propagated one hop, and then it will no longer be able to be sent any further into the network. So, for example, if I have R1 here, I have R2 here, I have R3 here, if I form an iBGP peering between these two guys, and I have, let's say R1 has an eBGP peering somewhere over here on the internet. What are you using for your lab? No, that is, it's eVNG. That's what I'm using for the lab. If I learn a route in on R1 from an eBGP peer, that route will get propagated down to R2. And R2 has an IAGP, so let's say OSPF here, peering to R3. That route will not get propagated down to R3. Now, if I have an iBGP peering here to this guy, will this route get propagated down? It will. Or, I'm sorry, it won't. And the reason why it won't is because the propagation isn't full mesh, which R2 and R3 don't have a propagation. So, actually, now that I think about it, this one probably will, this one will. But if I had any other way, it would not. So if I wanted to do a connection where R2 has a BGP peering to R3, but R3 does not have a peering to R1, then it wouldn't receive anything from R1. So full mesh gets a little quirky. So where I have a setup where we have, I think it's R7, XR22, R8, and then we have XR21. We have a full link connectivity. We're going to do a full mesh. So everybody will have a peering to everybody else. So I'm going to show you the right way to do stuff and how to get it up and running to eliminate any potential problem that you might have of getting connectivity up and running. So this is one of those things where knowing that you need to have it there will automatically help you understand and troubleshoot the problem. Where if you have a BGP peer that you have in your environment that isn't fully meshed, into the environment. If you're not doing route reflection, then you need to have you need to be peered with everybody else. That's simply just the way it's got to be. There's you can read up on BGP in more detail, but that's basically what needs to happen. I am a big proponent of route reflection, and the reason why I'm a big proponent of it is because it cuts down on the amount of full mesh connectivity. So if I start advertising, getting all these links up and running, and I start doing all these peerings, as you can see, these peerings start to get a little ridiculous, right? And I come up here and then I do connection back this way and connection back this way. That's a lot of BGP peerings for not a lot of gain, right? Now, if I have a eBGP peering to somebody else, so let's say this goes to R6 over here. I get an eBGP peering here. If I receive a route in from R6, XR22 is going to propagate it this way. It's going to propagate it down to R8, and it's going to propagate it down to XR21, which is what we want to do. We want it to do all that. And then they'll be able to propagate it to all of their peers, so on and so forth. So we'll have full mesh connectivity. That's really, really important when it comes to how BGP propagates routes. Now, another variation of this is going to be with route reflection. Route reflection allows us to eliminate a lot of those full mesh capabilities. So we have, I'm going to do, say, R1, R2, R3, then R4, R5, and R6. This guy right here will be a route reflector, and this guy right here will be a route reflector. What does route reflection do? Well, as the name states, it receives a route in and then reflects the route back out. I mean, the name dictates what the operation is doing. So what I do from the route reflector is I form a peering to a particular set of routers. So R5 will form with its peers, and then we'll be good to go there. If I go and I'm going to be doing a confederation, so this right here will be the sub AS here will be we'll say 101, and this sub AS will be 102. What will end up happening with route reflection just between these guys right here is if I have an eBGP route learned from here and an eBGP route learned here, what will end up happening is I will learn that route in, I will reflect it to R2, R2 will take that route and then reflect it down to R1. R1 receives a route in from eBGP, it takes that route, propagates it to R2, R2 then reflects it down to R3, and everybody's happy. That's the point of route reflection. And the same thing would happen if I had, because these guys are going to be iBGP peered. So R2 will form a peering with R1 and R3. R1 and R3 will not peer with each other, not directly. So any routes we need to propagate will be propagated between the route reflectors. The route reflectors will not be peered to each other. So we're not going to do this. That will not happen. So we're going to eliminate that right away. And we will be doing a peering between R1 and R4 and R3 and R6. That's supposed to be a 6. We'll do that, and this will be considered to be a confederation eBGP peering, because we're peering between the different confederations. Now, with that being said, we're going to talk about the last one, which is going to be the confederation. The confederation, in its simplest terms, let me go ahead and get out of the way. A confederation is taking a very large autonomous system and breaking it down into smaller autonomous systems. So if we have R1, R2, R3, R4, R5, and then R6, and we all belong to the same autonomous system, that means that I either need to do a full mesh of connectivity like this, which is just ridiculous. No one's going to do this. This is just not going to happen. This is a bad idea. What I recommend, what will actually end up happening, is what you can do is what we're going to be doing down here, where if this was not a confederation, if this was just a single autonomous system, we could take R2 and R5, make these guys our route reflectors, and then we could peer down to all of our PE routers, or the routers that connect to other autonomous systems, and we could set this up like this. So that would be connectivity, where all the route reflectors would have peerings down to other routers, and we'd be in really, really good shape. And then if we had eBGP routes being learned in from R3 and R6, that information we could propagate it to 2 and to 5 respectively, and then propagate it down from R2 and R5 to R1 and R4. That would work all day long. We're going to be doing something very similar down here, where we're going to put these guys in their own subautonomous system numbers, so you guys can see how that works. And then we're going to make these guys route reflectors, so that we're going to be doing confederations with route reflectors inside of it to get everything working. When you break down, I take a confederation and you start breaking it down into sub ASs, what you're basically doing is kind of like what you do with OSPF. You take like area 0, and then you connect off into area 1, and then you connect down into area 2, and then off of this one here you've got area 3, and so on and so forth. And that's really where the power of confederations comes into play, because it allows you to break up your BGP domain and give you a lot more scalability. So it's meant to help control the route propagation and give you easier traffic engineering and stuff like that. So that's basically how that comes into play. So what I'm going to go ahead and do now is I'm going to dive right into the config, and we're going to go ahead and get this process started. Let me go ahead and bring up the CLI, and we're going to start over here on Autonomous System 200. Autonomous System 200 will be started, and we're going to go in here and we're going to form full mesh connectivity with everybody. So first thing I have to do though is I have to make sure that I can reach everything. So I should be able to reach the loopbacks of everyone. Let's see, 7 and 8 are not. I don't see 8's loopback. Let me. Oh, somehow 8 got wiped. I don't know how that happened, but I will work on the other ones. I'll get 8 up and running here. It won't take that long to do. So on router 7, I'm going to go to global config, type in router BGP, and in this case here it's going to be 200. Now, when you do this, there's going to be the default, the IPv4 unicast address family is going to be turned on by default, where what will end up happening is we're going to form a IPv4 unicast peering to every router that we're peered to, or that we set up. If you don't want that to be on by default, you can turn it off. I'm going to keep it on for right now, but I'm going to turn it off in subsequent setups just so you guys can see the difference. So I'm going to type in a neighbor, and I need to peer to 200.2.0.21. So 200.2.0.21. And the reason why I'm going to go loopback to loopback is because if I don't, then if I peer directly to this link, so 207.21, if I peer directly to the link and this link dies, so does my BGP peering. So I'm going to do that. I'm going to type in remote AS is going to be 200. I'm also going to say that the update source is going to be loopback 0, because I want to go loopback to loopback peering. I'm going to hit the up arrow, and I'm going to go type in .22 to peer to XR22, and do the same thing here. Get that all squared away. So there we have that. And then on router 8, I'm going to go ahead and throw the commands in there, but I had to go configure router 8 real quick and get him squared away. So let me go ahead and do that real quick on router 8. That won't take me long at all. Oh, it's not even done running yet. Let me go to XR21 and get him squared away. We'll go to global config. And what I'm going to do is I'm going to type in router BGP 200, and I'm going to type in neighbor. In this case here it's going to be 200.2.0.7. Type in remote AS is going to be 200. The address family is going to be IPv4 unicast. And I'm going to set the actually back up one up. The update source is going to be loopback 0. And one of the things I have to do underneath BGP is I need to turn the address family of IPv4 unicast on in order for that to work. If I do a show config, you can see my syntax. I turn the address family on, and then I also have got the peering started to that particular router. Now I can basically grab this information right here. I can basically copy this and hit the up arrow a few times and go to the neighbor config, which is right here, and go to the 21 has it set up. So I'm going to go type in 8 and then copy and paste the config in there like so. Makes it pretty simple to do the config like that. Now I'm on 21. Do I want to form a peering with 22? I'm going to do it just because of the fact that I can. I'm just going to show you that I don't need to be directly connected to it because iBGP has a TTL value of 255, which means I can be basically across the world and still form a BGP peering with you. So I'll do 22, copy and paste that config in. We do a quick show config, and there's our syntax. Pretty straightforward stuff. I'm going to go ahead and I'm going to commit that config. And then what you'll see is eventually router 7 will form a BGP peering with XR21. So that's all we've configured as of right now. Router 8 is ready to go, so I'm going to go ahead and quickly configure him. If we look at router 7, we can see that we have our BGP peering up and running. It's an iBGP peering. We go to router 8 real quick, and hostname is going to be iOS 8, and then on interface gig 0/0, IP address will be 200.8.21.8/24. We're going to no shut that guy. Go to gig 1, and we'll do 22, no shut, and then interface gig 0/4. Give that a couple seconds for the interface drivers to detect the up. And then we're going to go to here and do a 7.8.8 and then a no shut there. So there we have that, and then we're going to type an interface loopback 0. IP address will be 200. Let me move this over just a little bit so I can see it. 200.2.0.8/32. And I'm going to go to router RIP version 2, no auto summary, and we're going to type in network of 200 across the board. That will get us adjacencies with everybody, and I'm going to go ahead and save that config right there so we don't run into this problem in the future. Next thing I'm going to do once that's done writing the config is I'm going to give that a second to finish. Do show IP route RIP. Do show IP interface brief. Did I not no shut the interfaces? Oh, they just haven't started advertising routes yet. If I look at show IP route, the routing protocol hasn't kicked in yet to advertise the routes. Momentarily it will. RIP just takes a minute to do its thing. So, but I'm going to go back to 21. 21 has a BGP peering up, which we can see that. And I'm going to go to 22, and I'm going to configure him real quick to do the same thing. Now what's cool is on 21, I can do show run router BGP, and I can literally just take the syntax, I can copy it out of the router, I can pull up Notepad, and I can just dump this config into Notepad and make the little edits that I need to make. So instead of going, I'll go to 21 and then do all this, go to 22, log in real quick, go to global config, and then paste that syntax in and commit it. There we go. So once router 8 is online, I'm just waiting for it to, why is that not working? iOS 7. Do show run section RIP. That should be working by now. Oh, okay. Apparently I had to do these other network statements. So let me go ahead and just throw them in real quick. Oh, that's right, because we're in Class C ranges. We have to throw in those extra statements. So network of network 200.2.0.0. We'll do 7.8.0. We'll do 8.21.0 and then 8.22. I forgot about that. So we'll be good to go there. And then do show IP route. There we are. So now we have everything in play. I'm going to go ahead and save that config. Now in router 7, I'm going to go do show run section BGP. And we're going to go ahead and take the syntax that's right here, and we're going to copy it into here. And we'll go ahead and we'll remove this guy and say this will be 7 and this will be 7. And then we'll just copy. Keeps the BGP peering pretty simple, right? And then on router 8, we'll go to router 8, copy, paste, and then we'll form iBGP peerings with everybody else that we're peered to. Fairly straightforward stuff. So we're good to go there. Alright, so now we have all those peerings up and running from router 8. We'll do a show iBGP summary. I have 3 peerings up, 1 to 7, 1 to 21, 1 to 22, and I'm in really, really good shape. Now, let's move on to our little bit more advanced config. So I'm going to start off with a configuration where we do the Confederation, and this is going to take a little bit more time because in fact we have more routers, and we also have to do the route reflection. Once we get that in play, we'll then be able to move on to our eBGP peerings and get them all squared away. So that'll be pretty straightforward. So on router 1, we'll go in here. We have to verify that the underlying routing table. So we'll do a show IP route, eIGRP, make sure that we have all of our loopback addresses advertised. So we have, I can reach 2, 3, 4, 5, and 6, which is going to be needed because those are going to be the loopback addresses I'm going to be peering to. I'm going to go to global config here, and instead of doing the BGP peering that I did a minute ago, I'm going to use a different variation of it. So in this case here, it's going to be router BGP, and then we're going to use 100. But underneath here, I'm going to type in no BGP default IPv4, which is going to turn off the IPv4 unicast connectivity that's going to happen automatically. And what we'll do is we'll have to manually turn on manually activate the neighbor adjacencies that we're going to be forming. And what I'm going to go ahead and do is on here, I'm going to type in Confederation, or I'm sorry, BGP, and then Confederation, and then I'm going to put the identifier on this guy as going to be 136, and the peer that I'm going to be peering to, I'm going to be using, the peer I'm going to be connecting to is going to be 245, which is going to be, R1 is going to be peering to XR2. Can we handle that file and task for practice? If you become a member, you can download all that right away. So I'm going to go ahead and do the same configuration on router 6 and router 5, just so you guys can see that process. So on router 5, we'll go to router BGP 100, and then we're going to type in no BGP default IPv4. And then we're going to type in the BGP Confederation identifier. In this case, it will be 245 because we're on router 5, 245. And the BGP Confederation peer will be, in this case here, will be 136. And that's that. I'm going to do the same thing on router 6. We're going to type in router BGP 100, no BGP default IPv4, and then we're going to specify BGP Confederation identifier of 136, and then the BGP Confederation peer will be 245. Now that I had that in play, let's go over to XR2 and do the same thing. Over here on XR2, I'm going to go ahead and log in, go to global config, type in router BGP 100, and then underneath here I need to specify BGP, and then the same process applies to your Confederation, and I need to specify the identifier for XR2 will be 245, and my peer will be 136. Fairly simple stuff. I'm going to type in address family IPv4 unicast. So that's going to be the address family that we're going to be using. And then we're going to go ahead and begin our configuration of XR3 and R4. So on R4 is where I'm going to start. I'm going to go to global config here, type in router BGP 100, and I'm going to type in BGP Confederation identifier is going to be 245. I'm going to specify that I'm going to use a configuration enhancement. So the way that we can do this on iOS is we have a couple different options. We can either use the peer group, the BGP peer group command. What's that command? I'm sorry, it's neighbor, and then we specify, we'll say iBGP, and then we can say peer group, and then underneath this guy we can populate it with the details. We can type in the remote AS. In this particular case, we're going to peer inside of the identifier, the Confederation identifier. In this case here in router 4, it would be 245 because we're forming an iBGP peering inside of the Confederation. So we have that, and we can say the update dash source is going to be loopback 0, and that's all we're going to do for right now. We don't need to do anything else for the peer group. And I'm going to type in neighbor, and the IP address that we're going to peer to is, we're going to say for 100.1.0.2, we're going to say peer group is going to be iBGP. And then the same thing for 5. And if we go to address family IPv4 unicast, we're going to have to go underneath each one of these guys, type in activate, and we'll do 5 here. Okay, I don't know what this is all about, but I'm going to remove it. Because if someone's trying to troll me, do that. And then I'm also going to, when we do that, we do show run section BGP, what you'll see is the peer group configuration will also be added underneath the address family here. And what we need to do underneath here would be the neighbor 100.1.0.2, and we're going to type in we'll type in iBGP, and we'll type in route reflector client. Beg your pardon, not an internal client, neighbor. Can and can we put this person in, let's say timeout? Yeah, I can put that person in timeout. So, oh, I see what the problem is. So we can't use the configuration identifier. We have to use the 100. That's my fault. I forgot about that. So neighbor iBGP remote AS of 100, and then address family IPv4, then neighbor iBGP route reflector client. There we go. And then we'll go underneath do show run section BGP again, just to verify the config. And what I need to go do is, because we're underneath the peer group, we'll automatically get the route reflection because we're underneath the peer group, the route reflection capability will automatically be associated to this particular neighbor. And then what I'm going to do is jump onto R5, and I'm going to type in neighbor of 100.1.0.4 remote AS of 100, and then the address family IPv4, go ahead and just activate that adjacency. Or I should say activate that peering. So that will bring that peering up and running for us. There it goes. Do show run section BGP. And well, I can literally just copy and paste this. I can edit it a little bit and put this on 1 and 6 to get it going. So I'm literally just going to do this config right here. Going to pull up Notepad one more time. And we'll be able to say the neighbor that we're going to be peering to is going to be 3. So I'll change this over to be 3 and 3 here. And I'll be able to copy and paste this into 1 and 6 respectively. So let me go to router 1 and paste this in, and go to router 6 and paste this in, and then I'm going to go to XR6. I'm sorry, XR3. XR3, I have to go ahead and log in, and then router BGP 100, address family IPv4 unicast, and then we're going to say that the BGP Confederation identifier is going to be 245. I'm sorry, this here 136. 136 here, and we're going to type in the neighbor statement, neighbor of 100.1.0.1, remote AS of 100. Update source is going to be loopback 0, and then address family IPv4 unicast. We're typing route reflector client. So show config. You can automate the config on XR as well through a neighbor group or a session group. I'm choosing not to do that right now. We'll go to router 6, paste that in like that, and then I'm going to go ahead and commit that config. We'll give that a couple seconds to form its peering, and then 1 and 6 should form a peerings with router 3 here momentarily, which I just did. So 1 and 3 are now up and running, which is what I want to have. All right, so but the last step for me to go do, if we on XR3, if we were to do show BGP IPv4 unicast summary, we would see that I have 2 peerings here. If we look at router 4 and do show BGP IPv4 unicast summary, I have router 2 is not up yet. I haven't configured 2, that's why. So let me go underneath here and type in neighbor of 100.1.0.4, remote AS of 100, update dash source is loopback 0, address family IPv4 unicast. Commit that config. That will get router 4 and router 2 operational. And then once that process is complete, we'll have all of our iBGP peerings done inside the confederations. There we go. The next thing for me to go do is peer router 1 to XR2. So on router 1, I'm going to type in neighbor of 100.1.0.2, remote AS of 100, and then address and then the update source is going to be loopback 0, and then address family IPv4, going to activate it, and then XR2, same thing. Neighbor of 100.1.0.1, remote AS of 100, update source, loopback 0, address family IPv4 unicast, commit that config. Now I'm going to go over to do the same thing on 5 and 6. And on here, be neighbor of 100.1.0.5, I'm sorry, 6, remote AS of 100. The update source will be loopback 0, address family IPv4. Go ahead and activate it. And then on 6, same thing. Neighbor 100.1.0.5 remote AS 100. Update source is loopback 0, address family IPv4, and then activate. Alright, so we've got all of our steps in place now, and we should start to form peerings there. Router 1 and 2 are now up, which is what we want. Now that I have all that in play, now we need to do our eBGP peerings. The eBGP is relatively straightforward. I'm going to go ahead and I'm going to stop this video because we've gotten to the point where we have everything up and running. So the eBGP side we'll take care of in the next video. So until next time, guys, thanks for stopping by, and I'll catch you guys in the next video. All right, let me take 1 second here. How's it going, everybody? In this video, we're going to go ahead and take a look at setting up eBGP between all of our neighbors and getting all that squared away, and then do the route propagation. So configuration-wise, pretty straightforward stuff. I'm going to go to start on iOS 6. Actually, you know what? I'm going to do 5 to 17 first. I'm going to get this propagation to happen. So on 5, since we're the provider, we're going to start here. I'm going to go in here, I'm going to type in underneath router 5, I'm going to type in neighbor of 100.5.17.17 remote AS of 65100 and address family IPv4, and go ahead and activate it. Okay, now on 17, come over here, show IP interface brief. We've got this guy right here. We're going to go to global config, router BGP. In this case here, 65100. I'm going to type in neighbor of 100.5.17.5, remote AS of 100. Now after a couple seconds, we should get a what happened there? So what it's basically telling me is that the config is wrong. Did I do show run section BGP? Did I accidentally put it in 100? No, it's in 65100. Why is 5 giving me? Let me just go ahead and say no router BGP 65100. That should not have happened. Why is this giving me a hard time? Do show run section BGP. Sorry to hear that, man. That sucks. So let's do ping 100.5.17.17. I can ping it. Why is that? I wonder if 17 was giving me the squawk. Because this guy right here is telling me, I hope it's not telling me that they can identifier. Do I have them reversed? I hope I don't. We go to the calculator. You can calculate what the information is giving it to you. If you go to, I think it's scientific. No, it is programming. Yes, and you plug in this value right here. You do 00F5. No, so I need to go to hex. And it's clear. It's 00F5. Okay, so the identifier is, I got it backwards. So it's supposed to be in not that big of a deal. I can fix that. So I had it reversed. That's okay. I can deal with that. On here, I'll type in router BGP, and it's supposed to be. I'm technically supposed to have them reversed. So what basically is happening? That's my mistake. Instead of having, this is supposed to be your public autonomous system number, or sorry, your identifier is actually supposed to be your actual public IP or public autonomous system number. This value right here is supposed to be your Confederation number, but I always thought that was reversed. But because right now 17 is saying, well, you should be in 245, but you're not. You're telling me you're 100. So I can just change that around a little bit. So router BGP 65100. Type in neighbor of 100.5.17.5 remote AS of 245. That should get the peering up. There it goes. So that was my mistake. I had it reversed, but no big deal. So that gets that peering up and running. And what I'm going to go do is a do show run, or I'm going to do a network command underneath here of 100.5.17.0 mask /24. So that'll get the route propagated to 5. And if I do show IP BGP summary, I'm learning a route in from router 5, and you can see that it's coming in as 65100. That should get learned by 4, and it is. I'm learning it from 4. Now if I go over to 6, do show IP BGP summary, I'm learning it in, and you'll notice that it's coming across, which is what I want to see. And everything's looking pretty good there. So if I look at XR3 and hit the up arrow, did I not update it right? Router 6 is receiving it in. Why is it not showing up right? I'm receiving the route in, but XR is do show IP route. It's not installing it. No, it sees it as an eIGRP route. Oh, that's why. Because it sees it as an internal route. How did that happen? How did I learn it that way? I wonder if 5 accidentally has it set up this way. So do show run section eIGRP. I wonder if that's what happened. That's what happened. I've got eIGRP enabled on every interface starting with 100. So I need to go on underneath eIGRP, underneath this guy, and I'm going to type in AF interface is going to be gig 0/2. AF interface is going to be passive interface. So that should take that propagation down. So if I go to 6 now and I do show IP BGP, it should not be learned via eIGRP anymore. Hopefully. 517. So right now, this particular network right here is actually being advertised into eIGRP, and that's why we had to. It should get removed. The passive interface command should take care of that for me by having it there. So let me go to 5 and let me exit out real quick, and I'll type in network statements for what I need to have in there instead of doing the broad statements. So I'll specify I need to go network of 4.5 100.4.5.0, 0.0.0.255, and then 5.6, and then network of 100.1.0.0, 0.0.0.0, 255. Do show run section eIGRP. When you make mistakes like that, that could potentially cause you a lot of headaches. So I'm going to remove that broad network statement. Pull this network statement out, the 100 all. And then that should remove the propagation from here. There it is. Now it's being learned via BGP. Right there. XR3 should now be learning it in. Why is he not learning it in? That's really weird. 6 is receiving it. Do show iBGP summary. Am I not advertising it? Show iBGP. What is the command I'm looking for? I want to see advertise routes. Neighbors. And then 100.1.0.3. And then advertise routes. I'm not advertising any routes to him. Why am I not advertising any routes to him? And he's not a router. XR3 should be set up as a route reflector. So do show run BGP. He is set up correctly, I believe. And then 6 should be peering show run section BGP. Not sure why it's failing. Let me see here. I may need to do... We're not doing any MPLS, so I don't need to advertise MPLS with it. I wonder if that has something to do with it. 136 and 245. Let me pull this command out real quick. I don't know why that's there. I shouldn't be peering with myself. Do show run section BGP. Unless I need to set the next top. That might be part of the problem. Let me see if that fixes the problem. Why am I not advertising any neighbor 1.0.5 receive routes? Okay, I need to do the soft reconfiguration inbound. Should have known about that. Let me go ahead and soft reconfiguration inbound. And let's do a clear iBGP star soft. And hit that up arrow, receive routes. Okay, I'm receiving that prefix. And if I do the advertise routes, why am I not advertising it? I don't understand why I'm not advertising it. Oh, I know why. So the reason why I'm not advertising is the next hop is wrong. So my next hop is pointing it towards 17, so I need to change, router 5 needs to be the next hop self. So that's what I forgot to do. So do show run section BGP, that's right, I forgot about that. So these are why I'm glad I run into these problems. I know how to fix it, it's just a matter of analyzing the problem. So right now on 6, I'm just peering with it. So let me go ahead and just grab this config and let me say next hop self. Because basically what's happening is on router 6's side, he's receiving it and he's saying, I'm receiving the route, but you're telling me that because it's an iBGP update, you're basically telling me that 17 is how I get there and I don't know how to get there. So if I do a show iBGP, if I do a clear iBGP star soft, I think 5 has to push it. Do clear iBGP star soft. Go to 6. Now it changes it. So now if I go to the advertised routes, that should change it to, now 3 should be receiving it. Show BGP summary. That's really weird. Why is it? I know how to reach it now. Let's do a clear iBGP star soft. Do an update. I'm not advertising it to him. Not that big of a deal, but it kind of is. So what I need to go do now is configure the reverse way. So 6 show run section BGP. I need to configure 5 and 6 accordingly. So I need to go over here to 5 and type in next hop self and do clear iBGP star soft, because I'm going to have to go set up a peering. Let me do the peering between XR2 and 16 first. So on 16, show IP interface brief. This guy not set up yet? That's okay. Let me just go ahead and host name is iOS 16. Interface gig 0/1. IP address is going to be 100.2.16.16/24. No shut it. And for eBGP you're correct, but not for iBGP. So we're going to go ahead and router BGP 65100. We're going to type in neighbor of 100.2.16.2 remote AS of, and I have to remember the Confederation ID in this case here. I'm going to have to reverse that. And then network of 100.2.16.0 mask /24. Then on XR2, let me do this. Cisco, go to global config, and then router BGP, in this case here 100. I'm going to have to specify a neighbor of 100.2.16.16 remote AS of 65100, address family IPv4 unicast. Now, in order for these routes to be learned, or accepted anyway, I need to create a route policy to accept the routes. So I'll type in route-policy. I don't have one created, so I'm just going to call it RPL eBGP. I'm sorry. I need to type in, what is the command? It is pass. And then accept and do a show config. And then I need to take this guy again. And I need to type in route-policy RPL eBGP in and out. And that'll be the config that I need to process. So just do a show config real quick. The RPL is needed in order to accept the routes. But that's for eBGP peers. So I'm going to go ahead and I'm going to commit that config. And we should get a BGP peering to 16 here momentarily, which we do. So now I should have an XR2 do show BGP summary. I am learning routes from 4. I'm learning those routes in, which is what I want to see, which is awesome. Now I get to go to 6, show iBGP. Currently I'm not learning anything from 16 yet. That's okay though. And what I'm going to go do, let's see, is 5 learning anything? Do show iBGP. I'm learning it from this guy. Now, if we go to 6, eventually I'll start learning stuff from 5. At least I should. And then what we'll do is jump over to, I can do the peering here. Part of me is thinking I should just rip out the Confederation config and circle back to that. I think that's what I might do. Might be just easier to do that than it is to continue to try to do the BGP, the peerings the way that they are. But I'll do that in a different video. I kind of need to, because things are kind of broken right now. I think the Confederation is the reasons behind it. But let's look at, it's receiving that route in. 5 is seeing both. It comes in. Oh, I know. So I need to do the same thing on XR. So on XR2, underneath this, the peering to R4. So I need to exit out of here real quick and do show run router BGP. What I need to do on 4, let me grab this guy right here. Underneath the address family config, underneath here, I need to come underneath here and say next hop self. And commit that as well. So now, with that being pushed, 5 should now see it coming in as .2. 6 should see it, hopefully, clear iBGP star soft. I'm not sure why he's not. 4 is propagating it. Show iBGP. Let me go to 5 and do the same thing that I did towards 6. So do show run section BGP. I need to do the next hop self on that one as well. Give that a second to do its thing, and then I will grab this and then next hop self. Do clear iBGP star soft. So now that that's there, go back to 5, or I'm sorry, show iBGP. So I'm learning that in from 2 now. Now 16 or 6 should be seeing it now, and it's weird that it's not. All right, so now it's seeing where it's coming from, which is what I wanted to see. I've got the next hop set correctly. So 5 is seeing it. XR2 should be seeing 17. So show BGP summary. And I'm seeing those updates. I've got those updates set up correctly. And now I should be able to go to 6. Show IP route. Why is this not sending it the way that I need it to? Am I accidentally sending? Now, I know XR is specific to eIGRP, is only doing these peerings on these interfaces, so I'm actually not sure why it's giving me a hard time. Kind of perplexed at the moment, but it's not that big of a deal. I'm going to go between XR21 and iOS 6. I'm going to go ahead and set those BGP peerings up and get them squared away. Show iBGP summary. I should be learning something from, let me just double check to see if there's anything going on with 1. There's some syntax that I need to throw in here. So show run section BGP. So the peering to 2 and to 3, I need to set the next hop self on underneath the address family config. So let me go ahead and just do that real quick. Next hop self. And to 3. Do clear iBGP star soft. And XR2, I believe I show run router BGP. I think I did it to everybody, but on to 1 I did not. So let me go ahead and do that to 1 real quick. Get that squared away. Next hop self. In MPLS VPN, you don't need to do this. In regular internet routing, you do, because there's no labeling. You don't have a label switch path. So things are a little bit different. So 6. Is router 1 learning the routes? Do show iBGP summary. I'm learning a route from these guys, from 1, but he's not learning anything from either one of those, which is really weird. Am I... Show IP route. I should have reachability to these guys, which I do. Let's see. There's nothing spectacular about the setup either. But I'm not receiving any routes from 1. I wonder if... Let me take a look at the syntax again. I'm half tempted to, and it's update source, route reflector client. They're iBGP peers. There's no doubt about that. If they weren't iBGP, then the route reflector client config would fail. So, let's look at 6. But I'm only receiving 1 route in. Why is he not seeing 102? Sorry, I'm sorry. I need to look at this one here. Oh, you know what? I know what the problem is. And it would take a fair amount of reconfiguration to do this. I would need to flip-flop the, pull out the Confederation stuff, and then I would need to do BGP. So what's happening here, now that I'm thinking about it, is Confederations changes the way that BGP operates. So right now I have route reflector client here to here and here to here. But technically these are Confederations. And it's failing to work the way that I need it to. So a solution would be to remove the Confederations and circle back to that at a later point in time. And then from 4 to 6 and 3, set up route reflector clients this way. Do something like this. So XR3, so the route reflector clients of each other, and then the that would fix the problem. So that's what I'm going to go do, and I'm going to rip out the Confederation config, and then I'm going to set up a peering to each one of the route reflectors. That should eliminate the problem, because right now, because it's not a full mesh, it's giving the problem that I was trying to avoid, but we can fix this. So you're going to see me live troubleshoot it. So let me go to here and pull out the Confederation syntax. So no Confederation here, and no Confederation here. And I'm going to take these 2 lines of config and do something like this. I'm going to go over here to XR3, go to global config. Actually, let me go to router 6 because I'm in the same path. Router BGP 100, and just type those both in. Router 5. Get rid of the Confederation config here as well. And router BGP 100, and pull the syntax out. I'll come back to that at a later point in time. And then on 4, I'll do the same thing. Confederations are not very common to my knowledge. I have never seen one in production, so it's not exactly applicable here for the routing and switching track or for enterprise. It's more of a service provider thing. So let's go to XR2 and go to global config, router BGP 100. and pull those pieces of config out real quick and get this back on track real quick. And then XR3, I think I just have the, yeah. And then what I'm going to do is on R1, since I'm right here, I'll just type in neighbor of 100.1.0.4 remote AS of 100. The update source is going to be loopback 0. Did I forget to do that for 100.3? I think I might have. And the address family IPv4, neighbor of 100.1.0.4, activate, and then next hop self. I don't technically need that, but, well, I will because it's going to be eBGP updates, but I'm going to do that real quick, and I'll do the same thing for 6. Grab 6 real quick. Do show run section BGP. And I will add a neighbor statement to, how did I forget the update source to 3? That's weird. Could have swore I had that in there, but that's okay. We're going to do neighbor to 100.1.0.4 remote AS 100, and then update source loopback 0 address family IPv4, and then go ahead and activate that one, and we'll do a next hop self just for good measure, and that should get us squared away. We have to go to 4 and add those routes. So type in neighbor of 100.1.0.1 remote AS, or sorry, peer group is iBGP. Because I did remove the, oh, I need to remove that command here. We're going to say no and pull out the Confederation identifier. That's not needed anymore. And I bet you 17, the peering drop. No, they're still up there, which is good. 4. And then we'll do the same thing to 6. Address family, IPv4. And that pops up right away, which is good. Now I get to go the same thing 2 and 5. So underneath XR2, we're going to go to neighbor of 100.1.0.3 remote AS of 100, update dash sources loopback 0, address family IPv4 unicast, and then next hop self for this case commit, and then we'll do the same thing for 4 is already in place, so we don't need to worry about that one. And then we'll do the same thing on 5. We'll type in neighbor of 100.1.0.3 remote AS of 100, update dash source is loopback 0, address family IPv4, activate, and then next hop self. We're going to go to 3 and do show run router BGP. I've got 1 and 6 in here. I need to add 2 and 5. So neighbor of 100.1.0.2 remote AS of 100, update dash sources loopback 0, address family IPv4 unicast, route reflector client, show config, and I'm just going to copy and paste this in after I hit the neighbor statement. That'll be 5. And commit that. Alright, so now that that's been removed and we've updated the config, that should take care of any problems we potentially might have in terms of the operations. So we go back to 5 and we do a show iBGP summary. We're receiving the routes. We got the correct updates. If we go to 6, show iBGP, and there we go. So I'm learning it in, which is what I needed to have. We do a show IP route. BGP routes are being learned. Let's do a quick BGP. We see the routes are being propagated, which solves our problem. Now the next one we're going to do is we're going to go 6 to XR21. So on router 6, we're going to go to global config, router BGP 100. We'll type in neighbor of 12.6.21.21 remote AS of 200, and then address family IPv4. Do I have to do the activate? I do. We'll do 21, we'll do activate. And then we're going to go over to 21. Come up here. I'm going to create the RPL right away. So route-policy RPL eBGP. Type in pass. Keep it very, very simple. Router BGP 200. Neighbor of 12.6.21.6. Remote AS of 100. And then address family IPv4 unicast. And then we're going to type in route-policy RPL eBGP in and out and commit. So momentarily we should get a BGP peering to router 6, which we do. And if we jump out of here and do a show BGP, we should receive both of those prefixes. We have 2.16 and 5.17. I'm going to go ahead and on XR21, I'm going to go back to global config, router BGP 200, underneath address family IPv4 unicast, and I'm going to advertise this 200.21.45. So I'm going to type in a network of 200.21.45.0/24. I'm going to go ahead and I'm going to commit that. I'm going to go take a look at XR2, and I'm going to do a show BGP. I should have that prefix show up here momentarily. It'll take some time for it to propagate. 6 should see it right away. Let's see here. 21, since it's attached to 21, I already did enable the address family. The address family's already been enabled, man. So do show BGP. The route is there now. 6 should start seeing it. There it goes. It just took a couple seconds for it to propagate. And then XR2 should see it. He does, and which is what I want to see. And then 16 should have it. And I think my peering might have gone down because I changed. Well, no, that should be okay. Or no, you know what? Show iBGP summary. Yeah, my peering went down. So let me go ahead and fix that. Router BGP 65100. We're gonna do show run section BGP, and then we're gonna go and I'm gonna pull this command out. Neighbor of 100.2.16.2 remote AS of 100. That should get us adjacency back up. Or peering. I keep saying adjacency when I meant to say peering. There it goes. And show iBGP. And I get 200.21.45 received back in. Same thing with 17. Because my autonomous system changed on the other side, I'm going to go router BGP 65100. And we'll get that guy squared away. I'm just going to pull this command out. I'll come back and do confederations at a later point in time. Type in the neighbor command, but I'll do it to 100. And that'll bring a peering up. Now now that that's up, do show IP BGP. Beautiful, everything's working out there. I'm gonna go ahead and clear the screen off. I'm gonna go ahead and set up 8 to 46. So on router 8, if I go in here and show IP BGP, I should be receiving those routes, but you'll notice that on here it says 12.6.21.6. I need to go to XR21 and do show run router BGP. Underneath these peerings, I need to go ahead and add in next hop self underneath the address families. So what I got to do is grab the neighbor statement real quick, then address family IPv4 unicast, and then next hop self. Do the same thing for 8, and then 22. Go ahead and I'm going to commit that config on 21. Now I'm going to go over to router 8, and now that they've been updated to the loopback address that they can reach, now we're in good shape. I'm going to go over to here and type in router BGP 200. Type in neighbor of 200.8.46.46 remote AS of 65103, and then I'm going to go over here to 46. Pardon me. I'm going to type in router BGP 65103, and then neighbor of 200.8.46.8 remote AS of 200, and then I'm going to type in network of 200.8.46.0 mask /24. Just like that. Now on 8, I have to go back to do show run section BGP, and I have to set the next hop self command on all of my adjacencies as well, or on my peerings, because right now they're not set. So underneath here, I have to say next hop self on 21 and then 22 respectively, and do clear IP BGP star soft. Alright, so now if I go to, now that that's in play, I should be able to go to XR2, and after it propagates, this will take a minute or so, so don't be surprised if it doesn't show up right away. If I show IP BGP, I'm directly wired to it, so I should see this propagate here momentarily. If I do a summary, I am at an idle. Why am I at an idle? My peering has not come up yet. Why did it not come up yet? Do ping 200.8.46.8. That would be why. Let's go check out router 8. Show IP interface brief. And I don't have that interface configured yet. That would be a good reason. Let's go to interface gig 0/2, IP address of 200.8.46.8/24. No shut it. And I'm going to do write and save the config. Okay, now that we've got that in play, our BGP peering should come online here momentarily. And it does. Do show IP BGP. The route gets advertised from 65103. XR2 sees it almost right away. So I should have reachability from 16 to 46. So let's go to 16. And there it is. So we're going to ping 200.8.46. 200.46. Let's make sure that 46 can see the return path. Show IP BGP. Show IP route. I have 100.216 in the routing table. So why am I not able to reach it? Just because you have control plane reachability doesn't mean you're going to have data plane reachability. So why is that? So we're going to have to go take a look at this in a little bit more detail and figure out why we're not able to get to where we need to be. So I'm going to go ahead and scoot this down just a little bit. So 46, I look at it, I have reachability to 16. 16 should have reachability to 46. If I do a trace route to 200.8.46.46 numerically, well, that's not good. What's that tell me? I have a loop. So I jump into the service provider network, I hit router 2, then I go to router 4, then I go to router 3, then I jump over to router 1. For some reason router 1 takes me that path. It takes me back to router 1, then it tells me to go back to router 3. That's an internal routing issue on inside of this core, and the reason why that's happening is if we look at router 1 and do a show IP route eIGRP, you'll notice that we have a default route in the routing table because we don't actually know how to reach that particular prefix. We don't know where to go with it. We have no idea how to reach the 200 network. So what I've got to go do is on, I think it's router 5, I am show IP or show run section eIGRP. I'm advertising a default route. And this becomes part of the problem with reachability issues. So what I'm going to go do is underneath this guy right here, I'm going to remove this default route. No summary address. That's going to resynchronize those adjacencies. And remove the default route. So now I'm going to go back to 16 and run that trace route again. And now I get to router 3. Router 3 is like, I don't know what to do with it. So router 3 is like, well, what gives? Now we could wait for it to figure itself out. But if we go to XR3 and we look in the routing table, show route, we look in the routing table, whoops, let me scoot this up. We look in the rib, we don't have no clue how to reach anything 200, right? And that's one of those things where when you're dealing with this type of routing, this is the more complicated routing to go through than it would be if you were dealing with MPLS VPN. You wouldn't have this problem with MPLS VPN because you would have a label switch path to tie to, and you'd be using LDP to get from the ingress PE to the egress PE. All that stuff would be figured out for you. We'll talk about that in a different set of videos, but the problem we have right now is XR3 is like, well, I have no idea what to do. I've got a couple routes advertised, right? I've got 100 here, but I've got 105.17. I've got that advertised from router 5. But if we look at the show route BGP, we see 100.216, but we have no idea what to do with the rest of it. So that's a problem, right? So if we look at router 6, who we're receiving the 200 routing from, right? Do a show IP BGP. We can see that we're receiving those prefixes in from a next hop, right? We look at router 5, show IP BGP. We're receiving those routes in from the loopback address of router 6. XR3, we show IP BGP summary. We're receiving stuff in from 6. Specifically, if we look at this, we can see we're receiving it in But it's just like, oh, notice that. It doesn't know how to, XR3 doesn't know how to reach that particular next hop. So all we have to do is back on 6, show run section BGP. I'm pretty sure that on the peering to that connection, pardon me, I didn't want to blow your eardrums out. We are not doing next hop self on the 3 network. So we have to go up here, router BGP 100, address family IPv4, and on this adjacency, or this peering I should say, is set next hop self. Do clear iBGP star soft. So now that we've done that, if we look back at XR3, we can see now those routes are there. And if we go back to 16, let's try that again. We're able to get there all day long. So because of the fact that we don't need to redistribute any of the BGP routes into our internal routing, we just need to have a path from when we get to the ingress router on XR2. When we look at XR2, we know what next hop to point towards. So here we have the loopback address of router 6. So I'm going to actually stop this video and I'm going to walk you guys step by step through the BGP data plane path verification, because that's a really big one. This goes to show you that you can have control plane reachability, but data plane is just dead in the water. And I'm going to show you how to do the recursion process. So I'm going to start the next video up here in just a second. Give me 1 second. Hopefully you guys are getting something out of this. How's it going, everybody? In this video, we're going to go ahead and take a look at BGP data plane verification. So walk you step by step through the recursion process and how BGP figures out how to send traffic. So the way that this works is it's actually pretty straightforward, but you definitely have to understand how BGP ties to the routing. BGP and iGP work together in this particular situation. So if I'm on 16 and I do a show IP route, well, I'm glad it's helpful for you there, Anthony. I'm glad that glad that works for you. If I want to get to this particular next hop, or I'm sorry, this particular prefix, I need to know how to get there, right? Remember what I was talking about earlier? I don't know if you were, for those of you that are just joining, or if you've been here for a little bit, that in order for you to get to where you need to go, you need a way there and a way back, right? So what we do is on 16, we know that we're going to go to a next hop of 100.216.2, okay? 100.216.2 gets us to XR2, okay? XR2, when we look at the BGP table, we look at this for the same prefix, it says 100.106, okay? When we go in the AS path, we can see that the original AS that originated this was 65103. In this case here, that's going to be router 46. That's the autonomous system number he sits inside of. You have AS 200 as the first AS that he passes through. So this is a transit AS. This is the originating autonomous system. This is your transit autonomous system. When you look at 16 and we do a show iBGP, we're going to have 3 autonomous systems. We're going to have the originating autonomous system, and then the transit autonomous system of 200, and the transit autonomous system of 100. So 100 and 200 are both transit ASs. We're using those to get from one source to one destination. On XR2, we can see in order to get there, we have 100.106. So, but if we look at the BGP table, show IP route BGP, we have no idea how to get there, right? BGP is completely unaware of how or what 100.106 is. It's oblivious, right? So how do we fix that? How do we get to where we need to be? Well, the simple answer is we have to look at the iGP routing table. This is the key reason why you would never use BGP to replace your iGP. So for those of you that, that I don't want to say necessarily argue, but debate IGP versus BGP internally, this is why you don't use BGP internally. Could you advertise these routes and make it happen? You can, but it's awfully dirty. It's not a good idea. So if we look at the show route eIGRP, because we know eIGRP is our internal routing protocol, we're going to find 100.106 and we're going to know how to reach it by these two different ways, which means that from a routing perspective internally, in order to reach the loopback of router 6, I need to either send traffic this way or send traffic this way. That gets the job done, right? And then if you were to go to router 1 and do the same lookup, it would tell you to go this direction. If you were to look at router 4, it would tell you to go this direction or this direction. XR3 is going to tell you to go here. iOS 5 is going to tell you to go this direction, right? So they all point, they know how to get to where we want to go. And that's why when you do an internal trace route, for example, let me go back to the pencil. If you trace route 100.1.0.6 from a source of 100.1.0.2 numerically, you need to have a IGP known path and how to get there. That's a really, really important thing. As long as you know that, you're in good shape. Now, that gets us to iOS 6. iOS 6 is where that eBGP route is learned from, right? So we take this and we do a show IPBGP. We know how to reach 200.846 from 12.6.21.21, right? That's going to be the AS path, or the next direction we need to go in order to reach where we're trying to go, which is XR21. As an eBGP peer, we know that because our internal, our BGP autonomous system number is 100, theirs is 200. We know it's an eBGP route. So what we get to go do is we get to go jump over to XR21. We'll go ahead and log in. We'll do a show BGP. We know that 200.846 is internally known via iBGP. We know that because it's right there. And we have a loopback address that we're going to be using to point towards. It's a public IP in normal terms, but we get to where we got to go from there. So how do we know how to reach 200.208? Show route BGP. Well, we certainly don't know how to reach it via this. There's no route to that destination here. If we do a show route RIP, we're going to see 200.208 here by a gig 000. So we know we need to recurse that way in order to get to where we got to go. And that's basically where that process comes into play. The next step for us to go do is to jump over to router 8, show IPBGP. We see 200.846 right here. Now this R right here means a couple different things. It means that this route is learned via another path, not BGP. So it could be learned through an IGP with a better administrative distance, so anything better than 200 or what iBGP uses. Number two, it's directly connected to us. It's one of those two things. So if we look here, do a show IP interface brief, ta-da, gig 02 is 200.846. So we know that's going to be the kicker here when we do this. So with that being said, when the recursion comes into play and we go to router 46 and we do a show IP BGP, we're receiving a bunch of routes. We can see where traffic is being originated from and going to. We can see that 200.21.45 is there. So if I was to ping 200.21.45.45, got another problem. No reachability there. What do we got to do to fix that one? On router 8, when we look back here, remember that we said that we advertise this link in here. So the problem is that router 45, when we're trying to ping it, if we look at router 45, you're going to be like, oh, that makes so much sense. Show IP route. Number one, we don't have any idea how to reach 200.846, meaning that we need to just do a default route, for example. So if we were to configure a default route, IP route 0.0.0.0.0.0.0 here to 200.21.45.21. Now that we have a default route, we go back to router 46, hit the up arrow, bam, we can route towards it. So that's where that type of stuff comes into play. As long as you have a pointer, if the provider is doing provider aggregation, meaning if they're advertising the prefix for you, your router needs to have a default route pointed towards the provider. In the event that the customer is doing their own route advertisement, so for example, in this case, your router 46 is doing his own route advertisement. He's got a peering up, he's doing his own route advertisement. Then you don't have to worry about that because you're automatically propagating the route for it. But since we're not doing that on router 45, we have to have a pointer on 45 back to the provider. Now, what if we wanted to have high availability? What if we wanted to have this connection here also added? We could do that as well. We could go over to router 6 and we could go show run section BGP. We can add 100.645 here and go underneath router BGP 100, address family IPv4, and type in network of 100.6.45.0 with a /24 mask. We've got that going on for us now. So now I could go to iOS 45 and I can put this default route in here and point it to this guy and type in 100.6.45.6, but I can put an administrative distance on this of, say, I don't know, 10. The cool thing about this now is this is now a backup route. So do show run pipe include IP route. What we just added to this setup is a level of high availability. So the connection goes down towards XR21. I have a backup route towards router 6 on a different autonomous system number. So that gives me flexibility there. So that's basically how you would want to go about getting all this stuff squared away and operational. So let's just go ahead and make sure that we have reachability from everywhere to everywhere before we cut out and end this stream. So 45, from here I'm going to do a ping to 100.2.16.16. I'm going to do 5.17.17. I can reach that, and I can ping 200.8.46.46. I can reach that. So because I have connectivity via BGP everywhere, that means that when I go in to do other things like, for example, DMVPN or FlexVPN, because 45 and 46 will be our DMVPN and FlexVPN spokes, we'll be able to reach them. We'll be able to get there all day long. With that being said, ladies and gentlemen, that is it. So we are good to go there. So because of the fact that we have reachability everywhere proves that the connectivity is where we need it to be and all that good stuff. Kind of glad you guys got to see me troubleshoot a little bit and work my way through the problem. You have to first identify the problem, and then secondly, you have to be able to work around the problem. So those are some pretty big deals in terms of the day-to-day. If you run into problems, you need to know how to identify what the problem is and how to figure it out. So it took me a few minutes there to figure it out, but once I was able to pin it down, it was pretty easy for me to rectify it. So I jumped the gun a little bit with the Confederations. No big deal. We can always circle back to those at a later point in time. But that, ladies and gentlemen, is BGP. So I want to thank you guys for hanging out with me in the stream today. It was awesome having everybody here. And I will be doing this as we move forward. I'm trying to get the videos done as quickly as I can for... Actually, let me go ahead and stop the recording. I'm trying to get the videos recorded as quickly as I can so that I can get them out to you. I've slowed my... instead of doing a bunch of videos at one time, I'm releasing them one day at a time, which actually gives me more time because it keeps the view counts higher and stuff like that. So yeah, good stuff. If there's something you'd like to see in the stream in the future, please either send me your probably best bet is to send me a message in Twitter, or something along those lines, or post a comment on one of the videos and be like, hey, can you cover this? But pretty much that's what I wanted to cover in this video. Until next time, guys, you guys have a nice day, and I will catch all of you next Sunday. If something pops up, I'll let you know, but I should be on stream next... Actually, hold on a second. Will I be available to stream? That'll be the 22nd, so yeah, I should be able to. Yeah, I should be able to. Anyway, you guys have a nice day. I will see all of you next time, and thanks for stopping by. Take her easy, y'all.